First, Jared.
All right, thank you, Paul. Well, hello, everybody. My name is Jared Zelek, and along with myself and Tom McGrath, our company is Quick Start Software. We do, full-time Xojo development, really full-time programmers. So if you ever have any questions in the future, feel free to reach out to us. Today, I'm going to be talking about design patterns in Xojo. So let's take a quick look at the summary. So today what we're going to talk about is we're going to get into a history of design patterns, tell you where they came from, why they're important, really kind of motivate you and why you want to know about design patterns and how they'll help you with your Xojo projects. And then we'll get into the benefits, all the benefits of why you want to use design patterns. But, most importantly, we're going to say what design patterns are. And now with this whole background of design patterns that I'm going to establish, we're going to really drill down to a good example project. And this example project today that we're going to talk about is a weather simulator. And with this weather simulator, we're going to use 4 different design patterns to build an entire weather simulator. One example project, one design pattern we'll build on the next. Have a really good example of how to use design patterns, how to use them together, and the benefits they can offer you. After we go through all those demos, which will take up most of the time, I'll go into a summary. And after that, I'll have kind of a formal question area in case I didn't get to any questions. But I also stop for questions, after each design pattern to see if you guys have any specific questions about that section. So first, let's go into the history of design patterns. In 1977, Christopher Alexander was the person who really established what design patterns were. And he wrote a book called A Pattern Language. Now, the interesting thing about this is that this book wasn't about software development. It was really about towns, building, construction, and architecture. So the idea of design patterns actually didn't come from software. It came from architecture. And then in 1987, Kent Beck and Ward Cunningham, they presented a paper at an object-oriented programming conference. And that's really where it took from the design patterns to go from architecture into software. And in 1994, the seminal book on design patterns was written, and the 4 authors are known as the Gang of 4. And this book is called Design Patterns Elements of Reusable Object-Oriented Software. And when you hear most people talk about design patterns, they're referring to the design patterns in this book because it is the seminal text. And today, with design patterns, it's important to know that many patterns exist, especially if you have a specific, domain that you have, either systems architecture, programming. There's different patterns for each of those domains. However, there's no official list of patterns. So now let's talk a little bit about the benefits of design patterns. The first thing that design patterns will give you is they'll help improve your communication. So this is important because what a design pattern does is it's a quick way for you to express a type of software architecture. So if I would go to you and say, I want in my program, I want to write code where I don't instantiate objects all over the place, but I just have one central place to instantiate them, and I can use that object everywhere. That's kind of confusing, right? That's a lot of words to explain something. And if I use a design pattern to explain that, I can just say, well, in this part of the program here, I use the Singleton pattern. And just by me using the word Singleton pattern, because we have a common line of communication, we can understand each other and improve our communication better. The other thing that design patterns do is they help shorten the design time. So with design patterns, you have these tools that you can take off the shelf that other people have thought through and other people have made sure are good to use. And you can leverage those patterns in your projects, so you don't have to reinvent the wheel, and it will shorten your time to deployment. And one of the third major benefits of design patterns are that they improve the quality of your code. These design patterns have been passed down through the years. They've been vetted, been published in books. And when you use these patterns to build your application, you're going to know that you have quality designs. It's just going to make your application a lot better. So now let's talk about in more detail what design patterns are. So each pattern describes a problem. So that's the one thing you need to know about design patterns. So design patterns don't really have anything to do with necessarily user interface, right? They're talking about the underlying code, underlying architecture of your software. And the reason to go to a design pattern is because you have a problem. So that pattern will first describe the problem. And then one thing about these problems is that they happen over and over again in our environment. So these are problems that come up, time and time again that we can define a design pattern for to solve this problem. Then the design patterns go into the core of the solution. Now this is the interesting thing about a design pattern that might surprise you at first. So not only do we describe the problem that occurs over and over, and then we have the solution. The solution is in such a way that you can use the solution a million times over without ever doing it the same way twice. So this surprises a lot of people at first. You may think design patterns are just pieces of code you can pull off the shelf and just use, as is. But really design patterns are a pattern on how to implement your code. So there could be multiple ways to actually implement one design pattern, and different, programs could have the same design pattern, implemented with actually, slightly different variants of code. Now the nice thing is that most of the time the code is fairly structured and fairly the same, but you don't have to worry if you need to make little tweaks to your code to still, keep that design pattern. That's perfectly valid. And we'll get into some examples later that will show you this exact thing. And again, this quote is from Christopher Alexander about architecture. So just to recap, design patterns solve a recurring problem. They describe the general structure of the solution, but the implementation in code is not the pattern. And many implementations can exist. So the patterns we'll be talking about today, and that when most people talk about they refer to, are the gang of 4 patterns. And these patterns have 3 main areas. The first types of patterns are creational. These creational patterns deal with the creation of objects. So think about any time in your Xojo projects where you use the new keyword. That's when you're creating a new object. These creational patterns will revolve around that code base. And then we have structural patterns. So structural patterns are actually how you structure your classes themselves. And the third main type of design patterns are behavioral patterns. So what behavioral patterns do is they set up patterns for interactions between objects, between classes. So this defines, how objects should behave together. So here's the total list of the Gang of 4 design patterns from their book, and you'll see, each one categorized underneath what type they are: creational, structural, or behavioral. And today we're going to talk about 4 specific patterns. So we're going to talk about the Singleton pattern, which is a creational pattern, the adapter pattern, which is structural, and then the observer and strategy pattern, which are both behavioral design patterns. And before I go into the weather simulator and talking more about that in detail, I'm actually going to see if we have any questions. So right now I'm not seeing any questions. If you have any questions, feel free to type them into the question section. And I'll just wait another second here to see if any come up. Okay, so that sounds good. So we'll go ahead and move ahead, and we'll talk a little bit about what this weather simulator app is going to look like. So the base for all our design patterns today are going to revolve around a weather simulator application. What this weather simulator application is going to do is it's going to report a temperature value, and it's going to report a humidity value. And through our different design patterns, we're going to structure a whole system that is going to revolve around this simple way of simulating the weather. So the first pattern we're going to talk about with this simulator is going to be the Singleton pattern. Now the purpose of the Singleton pattern, which I alluded to before, is that it ensures a class only has one instance and it provides a global point of access. And now we're going to look at some high-level examples to explain this point. So before the Singleton, this is how you may normally code your project. You may want to define a new weather simulator called W1, and then you may create other weather simulators called W2 and W3. Now the problem with this is that I don't want multiple weather simulator objects to exist in my program. I just want one weather simulator object for the entire program, and I don't want to have this flexibility, this kind of trap where I can create new ones and perhaps confuse myself on which one I should be using. So still, if we look at without using a Singleton, we have a weather simulator and it creates objects, you can see that we could possibly get in our code 3 different weather simulator objects, which we don't want. Instead, by using the Singleton pattern, what happens is when we want to create a new weather simulator, the weather simulator actually stores the object reference in its class. And so when I ask for a weather simulator object, it gives me that object. And if I want to ask for another weather simulator, it'll pass me the same reference. And again, for a third. So you'll see the differences before, where I can create multiple objects for this weather simulator. In this example, I only have one weather simulator for my entire app. So it makes sure that I won't get confused, define multiple objects, not sure which one to use, just keeps everything very structured. So with that high-level understanding, let's go into a demo. So here you can see my Xojo project open, and the first thing I'll do is I'll go into the patterns folder, and a lot of times in your code, if you use a module, there's a very good chance that you're going to want to use the Singleton pattern. And so before I even go into showing you the Singleton pattern, what I'm going to show you is probably what a lot of you are doing now in your code, and maybe some projects and problems that you'll encounter. So here's a bad way to do a Singleton. You create a module, and you have methods down here. You have method 1, you have method 2, and you have method 3. Now the problem is, a lot of times you need to initialize some types of variables before those methods run. So you create an init method here. And this init method is kind of like a constructor because it needs to run before each method, but because of the way modules work, they don't have constructors. So what happens is, in each one of these methods here, you have to make sure you put the init call at the very top. And if you forget that call, then your code's not going to work properly. And the other thing you have to do is every time you add a new method, you have to remember to put this init. So even though this is a very simple example, and I'm sure you can remember this, the problem is when you get into a very complicated project, if you have to remember this init after 6 months or perhaps another developer picks up this project, it's almost guaranteed that this init is going to be forgotten. So this is the way not to do a Singleton, even though I'm sure a lot of people, I've seen it many times in projects. So if we look in more detail on how to do a Singleton, you'll see the main difference here is that instead of a module, a Singleton is actually a class. And one of the unique things about Singleton is that it uses shared methods and shared properties. So this first shared method here called mSingleton as you see, it's actually a singleton itself. So inside the singleton class, I have a shared property that is itself, okay? And it's private because we don't want people accessing that. Then we also have a method, a shared method called getInstance. And this is where some of the magic happens. We say, if the singleton is nil, if it hasn't been created before, create a new singleton for me and give it back. Now, if the singleton is not nil and has already been created, then just give me the reference from before. And one of the nice things about this is that it still allows you to use the constructor for the singleton, so you don't have to worry about the init method being in all of your other methods. But the one unique part about the singleton is you need to make the constructor private, because even though we're allowed to use the constructor here in the shared method, we say new singleton, we don't want anybody else using the constructor. This is the only place the constructor will be used. So you may be asking yourself, what happens if we actually want to create a singleton object or class? And again, the only way to do it is through this getInstance shared method. So that's the singleton in a general sense. Let's look at it in context of our weather simulator. So here you'll see we have a very simple weather data class, and it accepts a temperature and humidity value, and it essentially allows us to get that value back out. So whenever we're doing weather readings, we'll use this weather data class here. And then the weather simulator, we have the same exact thing set up that we showed before. We have a shared property, which is a weather simulator, and we have a shared method that allows us to get that. In this example, I have the property to give the weather simulator a name, and we have in the constructor, we have it to set the name to migrate weather simulator. So the weather simulator is a singleton. Now let's jump down to the user interface to see how this exactly works. So in the user interface here, I define a WSimulator object as a weather simulator. And I tell the weather simulator to give me the instance of itself. And then I just display the name. So just for our simple example here, I have two buttons. I have a new visual display and new data display. And I have the same code in each. I get the singleton object, and I show the name. So it's very simple. Let's take a look at how that works. So you see when I press the button, the message box comes up. Now the important thing to notice is that even though I have different objects here, they're really the same object under the hood because of the singleton. So at this time I'll stop, see if we have any questions about the singleton pattern. If not, we'll move on to our next pattern. Okay, so let's keep on going. So the next pattern we're going to talk about is the
Jared,
observer
just to
pattern.
interrupt, there was one question. I think I assigned it to you.
Okay.
Did it show up?
Let me jump back up. Just saw it now. So someone asks, let me pull the code back up so we can look at the specific. Closed it, but I'll bring it back up. I got a little late, but let's see. So the question is, what would happen if you type WS equals new simulator? So I think there are, oh, okay. So that's actually a good question. So let's take a look at that in some live code. So I'm going to comment out this code here that I have. And I'm going to say dim WS. Well, I think they want to say, let's say WS as new. simulator. And the problem with this is it's going to say the constructor of this class is protected and can only be called within the class. So this is the whole purpose of the using the Singleton design pattern, is that you cannot use the new keyword to create a new weather simulator. The only way you can create it is by calling getInstance. So again, this kind of forces us to be very structured with our code, and we don't have to worry about where different instances are instantiated. We know there's only one place that instance can be really instantiated. So that's a good question. Okay, so let's go ahead. Thank you, Paul. Let's go ahead and move on to the observer pattern. So the purpose of the observer pattern is to allow objects to observe other objects and be notified of changes. So let's take this purpose and see what it looks like at a high level, and again do the same thing and drill down to a very specific example in Xojo. So we have our weather simulator that we already talked about, and we know we're going to have different things that we want to observe that simulator. So that weather simulator is going to have a list of observers that it keeps. And different things that may want to observe the weather simulator would be perhaps windows. So here we have a window for a visual representation, and we have a window for a data representation. And we could have other classes or essentially a lot of different things that could be possibly observing this weather simulator. And what happens is the window may say to the weather simulator, whenever you have new data, please tell me what that new data is. So it's going to register itself with the weather simulator. And the weather simulator is going to keep a list and say, whenever I have an update, here are the classes, objects that I'll send that update to. And the same with the wind data. The wind data may want the updates. Weather simulator will remember that. And any other classes you may have. So when the weather simulator simulates the weather and it's ready to send updates out, it will actually notify those classes that registered with it on demand. So you don't have to worry about polling the weather simulator or doing any other types of tricks. It's really an on-demand type of notification. And all that information, all that list is kept within the weather simulator itself. So that's a high-level look at it. But let's go into more detail and see exactly what it looks like in code. So the interesting thing to notice about an observer pattern is an observer pattern is really made up of two interfaces. And these interfaces are a subject interface and an observer interface. So let's take a look at the observer interface first, because it's the easiest to understand. So if I'm a class that wants to observe something else, then I only need to implement one method to satisfy this interface, and that's the update method. And what this update method does is when it's called, it's going to tell me the subject that called it, and it's going to tell me the data that it wants to update me with. And the data is encapsulated in this weather data class. So if I'm the type of object that wants to receive updates, I just have to be able to implement this update method here on the interface, and I can receive updates. Now, if I want to be the subject in this design pattern, and I want to be able to tell other people that I've updated, there's a few more methods, but still not that bad. The first method that's important is register observer. And I receive a class or an object observer of the observer interface. So essentially what this method does is it says, if you want to receive notifications, you need to tell me that you want to receive them. And also, since people can, get on my list, I also need an easy way to take them off my list. So I have a method to remove the observer. And so now that we have our list managed of what observers want notifications, we actually need a way to notify them. So we have a method that will notify the observers. Now, if you're not familiar with interfaces, you'll notice that none of these methods are yet implemented. And that's the whole point of an interface. It just defines the general structure of objects. And once those classes implement those methods, then they'll be able to act as either a subject or an observer. So let's go ahead and look at some more detail and see what this looks like in our practical code with the weather simulator. So the first thing we'll look at the user interface. And I created this very simple visual representation of our temperature and humidity values. And if we go over here and look at the interface section, you'll see that I have enabled it to be an observer interface. So for it to truly be an observer, it needs to make sure it implements this method here. And what happens is, when it receives an update, if the data is not nil, it says display the weather data. And the method to display the weather data is very simple. It just takes the data out of the weather data object and assigns it to our user interface values. And just implementing that allows this visual window, right, to be an observer. I did a very similar thing down here with a data view. So this data view also implements the observer interface. And it also implements the update method. And you'll see if the data is not nil, it says display weather data. In this example, it takes the weather data, it does some different things. It gives it a timestamp, and so it shows the temperature and humidity. So you can see it handles the data a little bit different than our visual view. But the nice thing about the observer pattern is it makes this really easy to do. So now that we see the code where the data is actually handled once the notification is sent out, what we need to see next, though, is how do the subject actually know these windows want to receive a notification? So for that, we're going to go look at our weather simulator class again. And you see the weather simulator class implements the subject interface. And because it implements that interface, it has a few methods that it needs to implement. So the first thing you'll see here is that we keep a list of observer interface objects. And if somebody registers with the weather simulator to be an observer, you'll see we just simply append that observer onto our list. Likewise, if somebody wants to be removed, we get the index and the array, and we remove them from the list. Now, when the weather simulator is ready to update the observers with new data, what happens is the weather simulator gets the weather data from this call here. And this call right now is very simple. What I'm using is 2 random values to calculate the temperature and humidity. So it's not very exciting right now. We'll change that a little bit later. So I get a random temperature, random humidity value. And then I say for each observer in my list, I call their update method. So you remember, if you want to be an observer, you need to implement an update method. And this subject essentially loops through those methods and calls them and says, okay, I'm sending an update. I'm the weather simulator. And I have this data to tell you that is new. And you handle that data however you see fit in your update method. I have no idea, what you're going to do with this data. I'm essentially going to give it to you, and you do, as you see fit. So now that we've looked at the code, let's look back at the UI here and just show one more thing. So we have 2 buttons, new weather, new visual display, and new data display. So this gets a little bit more complicated, but still fairly simple. So we get a new weather simulator object from our Singleton, again building on the code from before. We ask the simulator for an initial reading so that we can have something to display when we display the window right at first, so we don't have to wait for updates. And then we create a new window. And this window will send it to simulating the data. And here's where we register our object. We say the weather simulator wants to register an observer, and it's this window we just created. Now, the interesting thing about this is it's set up in such a structured way that we can create as many windows as we want. There's no hard coding between any of this. I could create 1 million if I wanted, and they would all work the same. And to really show that as an example, let's take a look at the code running. So I click to open a new visual display, and you'll see the random temperature and humidity jumping all over the place. And because we're using the observer pattern and nothing is hard-coded together, I can create multiple displays. They all work the same. They're all getting the same data. They're all updating. And create forward here. We also talked about our data view. So let's take a look and see what that looks like. You'll see we're getting timestamp, temperature values, humidity values. And I can create as many of these windows as I want. And the really powerful thing about this is you can see that when I set up the view and I set up the observer pattern and everything, because I'm using this observer pattern, everything is really separated. The concerns of this programming is separated. So that keeps everything clean, allows me to open up multiple views, and every kind of class here really has one single responsibility. So you see I can close these windows, everything still works. I can open up new ones. So this will go on forever. And that's really the power of the observer pattern. So before I go on to our next pattern, I think I'm going to pause here because Paul has a few polling questions he would like to send out to everybody. So Paul, if you're there, go ahead and take over.
All right, thank you, Jared. For those of you that have attended these webinars before, you know I have some standard polls that we like to run. So I'm just going to go through those real quick here and let Jared get back to the next things he's covering. So our first poll is, what type of apps do you primarily create with Xojo? All right, and I appear to have most everyone voted here, so I'll close this one and move on to our next poll, which is a simple one. Do you have a Xojo Pro license? Great. And our next poll is, how long have you been using Xojo? All right, and our last poll is, how do you use Xojo? All right, that's it. I see no outstanding questions in the queue, Jared, so back to you.
All right, thank you, Paul. So let's move on to the next design pattern. Now, one thing I also want to let you know is that I'm kind of going over some of this code pretty quickly. And I know some of you would like to really drill down to the details and see exactly what's going on. So at the end of this presentation, I will give you a chance to get the source code and everything so you can really dig into this code yourself and see it offline. But since we only have limited time with the presentation here, I'm going to go, over a few things kind of quick, but I also want you to have the opportunity to kind of have the code and go into it in detail. So that might, make some people feel a little bit better that they're not rushed to kind of keep up with everything if they're not following along. But let's move into our next design pattern here. And the next design pattern we're going to talk about is the strategy pattern. And the purpose of the strategy pattern is to define a family of algorithms and encapsulate those algorithms and makes them interchangeable. Now, the way we're going to use this in our weather simulator is that we're going to create a weather generator interface in a group of classes. Now, currently with our weather simulator, it's not very exciting because the temperature and humidity are just being generated randomly. But what I want to happen is with this weather generator interface is that I'll be able to send a message to this weather generator, and it will tell me what the weather is so that I can report it to everybody that wants to observe the weather simulator. Now, the reason that it's so powerful is that I can actually replace that weather generator class with a class that would implement an algorithm for random weather like we have now. Or I could replace that class with a weather generator that would create weather for Orlando or possibly New York. And not only can I do this, not only can I replace the algorithm that is creating the weather, but I can do this on the fly. So I don't need to recompile my application. I don't need to change anything. I can run the program and change the algorithm that creates the weather. And the reason I can do this is because I'm using the strategy pattern. So let's take a demo and see what this looks like in code. So when we go into our domain information and look at our weather folder, we still have the weather data and weather simulators before. But now we have a new folder. And this is going to hold all my weather generator objects. Now the first thing we're going to look at is a weather generator interface. So this is going to define the interface of what it means to be a weather generator. And this is a very simple interface. It has one method, and it's get weather data. And you see when this method is called, it just returns a weather data object. So it's very simple to be a weather generator. Now I took the code before for our random weather, and I put it in this random weather class, right? We have the temperature and humidity. We create a random value based on 0 to 100, so it's very random, right? We package it in a weather data object, and we return that value. And then you can also see here that when we click on the interfaces for the random weather, that it does implement the weather generator interface. Actually, all these classes here do. When we look at Orlando weather, here what we see is I still use the random generator to a bit, but I'm more intelligent about it because we're moving into summertime. So the temperature in Orlando is 80s, 90s, and the humidity is very high. So humidity is 80 to 100. So unlike our random weather that ranges from 0 to 100, Orlando here we're going to get some pretty realistic values, some pretty high values. And I also have a New York weather class here. And this is a little bit different. New York, they're perhaps, kind of cool temperatures a little bit. Humidity is a lot less than Orlando. Even the temperatures are less. And you see these different algorithms here are all encapsulated in these classes. That's the whole point of the strategy pattern. We take the algorithm to calculate the weather out of the class that's actually doing it, and we encapsulate them in separate classes themselves. So, it seems like a lot of work possibly. And why exactly are we going to want to do this? Well, open up some of the objects here so we can get a good look at everything. And the reason we want to do this is because we don't want the weather simulator to be calculating the weather. We want it to have a weather generator object here, okay, that implements the weather generator interface. And then we can say set the weather generator to whatever we want. We can say set it to random, set it to Orlando weather, New York weather. And then when we get the weather data here from the weather simulator simply asks the weather generator to get the weather data. And then everything else that we talked about before, the singleton, the observer pattern, everything just works in conjunction with everything else. One thing I don't think I talked about before, but I also have a timer on this weather simulator class. And this timer is what drives everything. It runs every half second. And it tells, to notify the observers. And that's when the notify observers call gets called. So let's jump into the user interface here and see what we can do with this. So we talked before about our displays and the observer pattern. But now if we go over to this weather tab, we'll see that we can click on random weather. And if we click on random weather, what we do is we get the weather simulator from the singleton pattern, and we set the weather to random weather, to our random weather algorithm, essentially. And we can do that same thing for Orlando weather, and the same thing for New York weather. So you'll see that we're changing the algorithms on the fly here in the code. So let's take a look and see what that looks like in the actual application. So we have our main app. I'll open up a few displays here. I'll open up a visual display and a data display. And right now, we're set at random weather. You can see the values are jumping all over the place. But as soon as I click this Orlando weather here, as you remember, the value should go very high. And I click the Orlando weather, and you'll see temperature and humidity are staying very high because we're simulating Orlando weather now. Now when I click the New York weather, you'll notice they'll go in about the mid-range. So I'll click that now, and you see the weather temperature readings and humidity readings go into the mid-range. And I can switch between these at will. Just click the random weather, see it jumping around. I can click New York, see it's about mid-level. And we'll click Orlando, and you'll notice it's very high. Now you also notice that everything that we did before with the observer pattern, creating new displays, all that code still works. And it still works seamlessly with our new strategy pattern here. Clicking random weather, clicking Orlando weather, clicking New York weather. So that shows the strategy pattern. Right now I see I have a few questions, so I'll go ahead and answer those questions. So the first question I have is, what is in the constructor of Orlando weather? So that's a good question. Let's take a look. So in the constructor of the Orlando weather, it's very simple. I have a random object down here as a property, and the constructor simply creates a new class of that, so a new object from the random class. And that random essentially is what I use here in the get weather data. Use that mRandom, but I just have a high range. And that's how it works for all the classes. All the classes are technically built on randomness. I just set different ranges for Orlando weather, different ranges for New York, and different for Orlando. So that's a good question. The other question is, will the demo projects be available? And yes, we'll get those projects available to you so you can really dig into the code. So hopefully you see the power of the strategy pattern. It allows you to take different algorithms essentially that conform to a standard interface that you define, and you can really switch them in and out as needed. on the fly. So now let's move on to our final design pattern. And that's the final design pattern for today. And that pattern is the adapter pattern. Now the adapter pattern, the purpose of the adapter pattern is to convert an interface of a class into another interface that the client expects. Now a good example of this type of design pattern happened to me when I got my iPhone 5. When I received my iPhone 5, it had a new connector. It had a Lightning connector. But the problem was that all my cords that I purchased previously all had 30-pin connectors. So there was a disconnect from the interface my iPhone expected, the Lightning connector, and what I currently had, the 30-pin connector for my old iPhones. And the way I solved this problem was by essentially using the adapter pattern. Went to the Apple Store and I bought an adapter. So I bought a 30-pin to Lightning adapter and plugged in. Everything worked fine. And at an intuitive level, that's how the adapter pattern works. So let's try to relate this now back to our weather simulator demo. And this is our current setup for the weather simulator. And the problem is, what happens with our algorithms that generate the weather? What if we don't want to just use some type of simulated values? What if we want to use something like hardware values that we're actually getting from actual hardware device, perhaps an API on the internet? You'll notice here that it's very subtle, but the hardware, object here is a circle. And that's to show that the interfaces don't match up. So this hardware class that I have, this might be a class I get from somebody else. It could be an encrypted class. I may not have, control over all the source code. And it won't just plug right into my system I have here. So what do? Well, what you have to do is essentially make some room for a hardware weather adapter. And what this hardware weather adapter does is when the weather simulator asks for some information, it asks the hardware weather object. And it adapts the interface from the hardware weather object back to what the weather simulator is expecting. And once that happens, everything else in our system we talked about before, all the observer notifications, happen exactly the same. So really in this example here, the weather simulator, you can think of it as being my iPhone 5. Hardware weather is a 30-pin. Then we have the 30-pin to Lightning adapter, the hardware weather adapter right in between. So it's exactly the same principle. So now that we look at this at a high level, let's dig down in some code and see exactly what it looks like. So we'll go into the weather generator here, and you see I have a new folder called hardware weather. Now there's a hardware weather class, but this class is encrypted. There's a little encrypted icon here. I can kind of open it up, but I can't get to the source code. And the problem is the way it reports back to me is not in a standard way that works with my system, unfortunately. So what I have to do is create this hardware weather adapter. And what this hardware weather adapter class does is it keeps the hardware weather class as an object that's passed in through this constructor. So it has access to it. And what happens is this get weather data that really implements the weather generator interface that we had before. This get weather data will allow us to plug it into our system that we currently have. And what we do is we use the hardware weather, and we use that interface, which just has a get temperature and get humidity. We take those values, store them locally, and then we package them up into a weather data class and send it right back out with the get weather data. So the hardware weather class, we can't plug it right back into our system because it doesn't have a get weather data method. It only has this get temperature and get humidity methods, and those won't work with our system. So we take those values and we wrap them the way we need them with the get weather data. So let's take a look here in the user interface. You'll notice in the weather UI, I now have a hardware weather button. This is very similar than, like we did before. We use a Singleton pattern to get the weather simulator. Then here we create a hardware weather adapter class, and we pass in our hardware weather class. And then when we set the weather generator on our simulator, the weather generator is actually the adapter. So the adapter will make sure that the hardware weather is converted into what our system will need to work. So let's just take a look at this running in our demo project. We'll open up a few displays here. And we have all the buttons before. We have random weather it's on, Orlando weather, New York. Then I click on the hardware weather, and you notice that the values are very low. So, perhaps this hardware is at a place that's very cold right now. And we can switch between everything. Everything still works the same. You notice how we didn't really change any code from our other patterns. Everything just builds upon itself very nicely. But the key point about the adapter pattern is that you take an interface here that we have no control over, and we can use an adapter class to really fit it into our system very seamlessly. So I see I have a few questions here, so let's pause for a few questions. One question is, do you have more patterns? The Gang of Four book really has all the patterns kind of detailed in, as needed, and then you can code those, as you have. I think there's some more out here. But yeah, there's definitely a lot of patterns out. I mean, some of the interesting things too is when you get in some design patterns for your specific domain. In case you're working on specific areas, those are very interesting. But yeah, there's we have some more design patterns, but we'd be happy to share, and there are some other ones out there. So another question is, does the weather information come through a USB device? So everything here is simulated, but there's definitely nothing stopping you from having this weather class, actually connect to a USB device, connect to a web service, an API, get the data from that. The great thing about this setup is that even though it's simulated, you could just plug real-world code right in here, and it's going to work exactly the same. So I'm not hard-coded to any type of API or hard-coded to any type of hardware. Everything is structured so that it's very reusable, very sensible. Concerns are separated, and it's easy just to plug in exactly what you would need. So one question is, how are the links between both interfaces in the strategy pattern connected? Let's take a look at that real quick here. So with the strategy pattern, we create this weather generator interface. And all these classes here implement this interface. And the way it's kind of connected together is essentially up in the weather simulator. So the weather simulator has a property, a weather generator property, that has the weather generator interface. It can be anything that implements that interface. That's the great thing about interfaces. So it can be any of these classes down here, or any class in general that implements the interface. And then the weather simulator class can use this weather generator object and not even have to worry about these algorithms down here. Okay? Only thing that happens is it has a simple method that allows somebody to set what weather generator they want to use. So this is where you really set the random weather, the Orlando weather, the New York weather. And then this method, tells the weather generator to get the data, and the data is, sent back through the notification system that we set up before. So yes, another question is asking if we'll make a video available of this. I believe we will. So stay tuned for that. I'm sure you'll receive an update. So we only have a few minutes left, and it looks like we've covered most of the questions. So let's jump back into the presentation. So just to summarize what we've talked about today, we really talked about the history of design patterns, and we talked about the benefits. We talked about what design patterns are, and we really looked in depth at a weather simulator example. So in that example, we talked about the Singleton pattern, the observer pattern, strategy pattern, and adapter pattern. So if you have any other questions, please submit them. Just to recap, my name is Jared Zelek. You can email me directly if you have any questions in the future, support@quickstartsoftware.com. And also, what I like to do is, if you're interested in getting the source code, just go to our website, quickstartsoftware.com/Xojo, and I'll package everything up that we talked about, and I'll email it to you tonight. And, the nice part is that if we ever have any updates to this, if you have any questions, you ask a really good question, we'll be able to give you updates on the design patterns and keep you informed on what's happening. So that's really the end of the presentation. I'll check the question log here to see if we have any other questions that came in. So here's one good question. He asks about what's a good book for learning more about design patterns. So that's a good question because even though the Gang of Four book is really a seminal text on design patterns, it's very academic and it's may not be an easy read for you. So there are a lot of other books on design patterns. I have a few in my library here that what I'll do is I'll reference those and send kind of a link out with some more of those books. But yeah, there are some good books that are easily accessible, easy reads. But the Gang of Four book is really the seminal text on design patterns, but it's probably not the best place to start.
All right, that does look like it's it for questions, Jared. Thank you very much. I do want to let you know, getting lots of great feedback. People love it. You did a great job.
Great, yeah, thank you.
And I'm going to stop the recording now.